Good day, everyone. Welcome to Tabby Code, your go-to channel for everything programming. Today, we are going to continue our lectures on data types in Rust programming. Rust data types. Rust is a statically typed language, which means that it must know the types of all variables at compile time. While in this journey, we will see the data types we have, and why it is telling us that it must know the type of variable at compile time. And it is the compiler usually infer what type we want to use based on the value and how we use it. So when you are directing or you are giving a variable a form, you should know that okay, this form, this is how I want to use it. So that is what we are just going to be doing expository on in this aspect. So data types can be divided into two. That's scalar data type and compound data type. So under the scalar data type, we have four major scalar data types. That's integer type, the floating point numbers, the boolean, and the character type. So while going on, we are going to be breaking them down bit by bit and knowing how each one serve each other, where they are both used and how they are being utilized. So now moving on to the first data type that we're talking about, that's the integer type. You see, an integer is a number without a fractional component, and you know that this type of declaration indicates that the value is associated with should be an unsigned integer or a signed integer. Signed integer takes or starts with the I, while the unsigned integer starts with the U, and they take up the 32-bit of space. That's like you can see in the table below. That's the integer type in Rust. We can use any of these variants to declare the type of integer value. Each variant can be either signed or unsigned and has an explicit size. Signed and unsigned refer to whether it's possible for the number to be negative or possible for the number to be positive, and can be represented without a sign, that's unsigned, and with the sign, that's signed. It's like writing numbers on paper. When the sign matters, a number is shown with a plus sign or a minus sign. That's just like our mathematical equations in school, where okay, an answer is okay, we say you divide something and the answer gives you -5, you write -5. That's a signed integer. Why the unsigned integer doesn't need these signs, just straight to the point, like plain old numbers 0, 1, 2, 3, 4, 5, 6. So that's all on signed integers and unsigned integers. On to the next one, we have the floating point types. Rust also has two primitive types for floating point numbers, which are numbers with decimal points. Rust floating point types are F32 and F64, which are 32 bits and 64 bits in size respectively. The default type is F64. That is the one we use because of the modern PC build and everything. It's roughly the same speed as F32, but it's capable of more precision. Like it is better than F32, which because F32 is okay, like almost on the same level, almost the same thing, but with an higher advantage than F32. And I've given you an example of how you can apply a floating, just like if you are familiar with other programming languages like Python, JavaScript, and others that relate to this, like object-oriented programming languages. You understand that these floats are numbers with, okay, let's say 3.0 with a decimal point. Those are what we call floats or floating point types. Okay, so down to the numeric operations. Rust supports the basic mathematical operations you would expect from all the number types: addition, subtraction, multiplication, division, and remainder. It supports everything, all of them, like a basic calculator. That's why it is just part of like just Python and everything. How they support all mathematical operations. This one also supports integer division, truncates towards 0 to the nearest integer. Now you can see the code example I gave, and if you try raw test running this, you see the result and see that okay, this expression statement is a mathematical operator and evaluate to a single value, which is then bound to a variable. That's all about numerical operations in Rust programming. Coming down to Boolean. you have two type of values possible in Boolean. If you're familiar with other programming languages like JavaScript, Python, C or C++, the major output of Boolean is true or false. It can be false true, it can be true false. It's either true or it is false. So Boolean always gives this output as the result of maybe a condition, like a conditional statement. Okay, if so happens, then return true. If not, return false. That's just like an example of how you can use Boolean. So, and I've given an example on how you can input Boolean and get a true or false response. Down to character type. Character type is like a function or a data type, sorry, not function, the data type used to call or used to represent Unicodes, like what we know as emoji. If you're familiar with our social media, like our keyboard, what we know as emoji are the Unicodes. That's what this character type is used for. And you can, okay, let's add I cat equals, that's from the example I gave, the cat with this love emoji in the eye, in the both eyes. So that was just what character type is mainly all about. Down to the next one, which is compound types. That's second type data type. Compound type can group multiple values into one type. Can group multiple values into one type. Like, okay, I can input like 5 values into one single type. While we move further, we'll see more about it. And Rust has two primitive compound types, tuples and arrays. So now the next slide is going to be about tuples. Then from there we'll go to the next one, which is going to talking about the arrays. Now we're going to be talking about tuples. Tuple is a general way of grouping together a number of values with a variety of types into one compound. That's grouping different values. I can use my alphanumeric, different values into just one compound type. Tuples have a fixed length. Once declared, they cannot grow or shrink in size. That's once you declare a tuple that this is what I want. You can't add, you can't remove. It is fixed. We create a tuple by writing a comma separated list of values in parentheses. That's in brackets, as we know it as curly bracket, not curly bracket, curved bracket. Each position in the tuple has a type, and the type of the different values in the tuple don't have to be the same. It does not have to be like, okay, I'm using integers here, I'll continually use integers all through. I'm using alphabet here, I'll continue. No, you can use anyone, you can add any, you can use float, you can use normal integers, anyone that deems fit to you, you can use them in tuples. Just like you're combining list of values, different values together into just one compound, into a singular parenthesis, that's the curved bracket. And to call a tuple is, you can use the top function. If variable top binds to the entire tuple, because a tuple is considered a single element, a single compound element. That's from the example I gave below. To get the individual values out of a tuple, we can use pattern matching to destructure a tuple value, like in the next slide. Now from my last slide, I said this program first creates a tuple and binds it to the variable tuple. It then uses a pattern with let to take tuple and turn it into 3 separate variables, x, y, and z. Like I gave this tuple, okay, let top equals in parentheses 500, 6.4, 1. Now, and I said let x, y, z equals top. So I've reassigned this first value to this one. Now when I say printing, the value of y is in curly bracket y. The program takes this y, where this y is taking, this what is taken on. Like, okay, now if you look at the top now function, I said 500 for the first one, 6.4 for the second, and 1 for the last one. So now the x is representing 500, the y is representing 6.4, and the 1 represents 1. So when you ask to print y, it's going to bring out 6.4 definitely. That's how you can access tuples and return results. Now we are moving to the arrays. Arrays in Rust have a fixed length. We write the values in an array as a comma separated list inside the square bracket. You know, tuples were inside curve bracket. This is inside the square bracket. Square bracket is different from curly bracket or curved bracket. Arrays are useful when you want your data allocated on the stack rather than the heap, or when you want to ensure you always have a fixed number of elements. However, arrays are more useful when you know the number of elements you don't need to change. For example, if you are using the name of the month in a program, you probably use an array rather than a vector, because you know it will always contain 12 elements, which is 100% sure. So now if you look at the example now, I select months equals January, February, March, April, May, June, July, August, September, October, November, December. I have listed them. Now in the next slide we are going to be seeing more about how this can be called and how it can function well. Now you write an array type using square bracket to the type of each element, a semicolon, and then the number of elements in the arrays, like the example below. Now if you look at the example below, now I said I32 is the type of each element. After the semicolon, the number 5 indicates the array contains 5 elements. That's after the semicolon, I said okay, this is the type of the element I want. Then that's for the 32-bit length. Then and I said okay, 5 is the number of elements in this array. So now you can also initialize an array to contain the same value for each element by specifying the initial value, followed by a semicolon, and then the length of the array, the square bracket, as shown here. Now I said okay, let A be the initial value, then the length of the array should be what? 5. So now the array named A will contain 5 elements that will all be set to the value 3 initially. This is the same as writing A equals to 333, but in a more concise way. So I hope you understand that okay, I can say okay, I can use, instead of writing this one, I can also use the array to write okay, let A equals to 3. That's the initial value. That's what I want the array to be. Then I want the 3 to be in 5 places. I have defined it already. Is that 5? How do you access an array element? An array is a single chunk of memory of a known phase size that can be allocated on a stack. You can access elements of an array using the indexing like this, like I gave in the example. So I gave let A equals to 1, 2, 3, 4, and 5. And so let first equals to A, that's 0. You know how we call in programming. Our first number is not always 1, it's always 0. So let A first be 0, and let second be 1. So in this example, the variable name first will get the value 1, because that is the value at index 0 in the array. The variable name second will get the value 2 from the index 1 in the array. So that is just self-explanatory, which is always a law in programming. It's just like a normal rule in programming that even in computer, 0 is the first number, then 1, 2, 3, 4, 5, 6, 7, 8, 9. Because you know, the computer counts, like processes information in 0 and 1s. That's these bits for the binary digit. So binary system is where computer operates 0 and 1, 0 and 1, 0 and 1.